Good afternoon. We are in the Saxon Geometry book, Lesson 68, which is on page 451. It is entitled Introduction to Trigonometric Ratios. Now, I admit that we have already had the Investigation 7, which did introduce these again. But this is another way of displaying it, and I want you to hear them all. We're going to start with the warm-up. And number 1 says vocabulary. A blank is a comparison of two quantities by division. We're going to switch down to the notes. And the answer to that one is a ratio. Number 2, we need to find A. Now, if we look over here, we see A, we see 12, we see a right angle, and we see 60 degrees. Aha! So we see this is one of our special triangles which we memorize. So we'll go down to the bottom and note, in triangle section in your smart sheet, put these two triangles. And that would be the 30, 60, 90 triangle and the 45, 45. This is a review of the 30, 60, 90 triangle with sides that have a ratio, common ratio of 1, 2, square root 3. Well, we learn at 1, 2, square root 3 because the numbers flow, but 2 is in fact the largest of these numbers, being larger than square root 3. So it is the hypotenuse. Yes, the hypotenuse is always the longest side. So that's 30, 60, 90, and a review of the 45, 45, 90 is 1, 1, square root 2. With the sides each being 1 and the hypotenuse being square root 2. Now, mind you, if the side is b, then it's b times the square root of 2. So here we are back to number 1 to find A. A is the short side, 12 is the hypotenuse, and is a ratio according to our memorized sides of 2. So 2 times A is 12, therefore A is 6. Number 3, which expression correctly represents the perimeter of this triangle? Now this triangle is indeed our other special triangle of 45, which if one of them is 45, the other one's 45 with a 90-degree right angle. So yes, it is, and its relationship is 1, 1, square root 2. So if this is 1, this other side is also 1. And square root 2 is also 1 times square root 2. So that's 1 times the square root of 2, or x plus 2. So we have, starting at the top, we're going to go down, we have x plus 2. We're going to go over, we have x plus 2 again. And then we have x plus 2 times the square root of 2 as the perimeter. Well, here are our choices. If we were to add these together, we would get 2x plus 4. And both of these have 2x plus 4. And this one has square root of 2 times x plus 2. So we are going to choose B. I hope you chose that also. Now, the reason to go back to lesson 68 is the trigonometric ratios, which should be on your smart sheet from Investigation 7, is the definition, again, and I've written it out, that the sine of A is written as sine A, which equals opposite over hypotenuse. A review again. Cosine of A equals COS, cosine of A, which equals adjacent. So the side that is adjacent to the angle A over the hypotenuse. And the tangent of A is abbreviated tan A, which equals the opposite side from angle A over the I wrote it incorrectly. Opposite over adjacent. There we go. We'll fix that one up. And the reason for this review is to show you another little way to memorize it. If we take the S from sine, put it here, and the O over h. We know it's a ratio. And if we take the c from cosine and the adjacent over the hypotenuse, and if we take the t from tangent and opposite over adjacent, we have a little saying, a way to remember how to say it is SOHCAHTOA. So we remember this little made-up saying, Indian chant, if you will, SOHCAHTOA. So SOHCAHTOA is to help you remember sine is the opposite, ka, the c for cosine, is the adjacent over hypotenuse, and the tangent is opposite over adjacent. In the practice, which is on page, should be 453, they gave this triangle right here, triangle TVU, with sides 5, 12, and 13. This is another ratio, a whole number ratio, and there aren't too many whole number ratio right triangles. So it is a good one to memorize. If you're given 13 as the hypotenuse of a right triangle, then you know you can have your other ones memorized as 5 and 12, 5, 12, 13. Just a little note to help you solve a problem faster. We are supposed to find the sine of t. Well, that is written as sine t equals, and we remember that it's opposite over hypotenuse, and over here is t, the opposite is 12. So very simply, it's 12 over 13. So we know that the sine equals, and we put that in our calculator and we get our answer. The tangent of angle U here's angle U, so we're going to go opposite of U, which is 5, over adjacent, which is 12. So 5/12. And find x to the nearest hundredth. Now I wrote 0.0 hundredths. And I wanted to write x, but that would be confusing, or y, some number times the hundredths place, just to say that that is where we're going to round it. And so x is on a different triangle, and I will draw it. Triangle in the book. Sorry, it is not a triangle, but we tried. Of 39 degrees up here with W, Z, and Y. And we do have a length right here of 41. Now, it's not straight, but that's the hypotenuse. So if we're to find x, well, we know this is the angle we're working with, and x is over here. So x is the opposite. Well, the first relationship we know is that the sine of 39 degrees equals the opposite, which is x, over the hypotenuse, which is 41. Now, some simply algebraic manipulation here. We're going to multiply both sides by 41. These cancel out to 1, and we get 41 times the sine of 39 degrees equals x. And we put that in our calculator, and I hope that you've been having fun with these. It is helpful to always look or to write down SOHCAHTOA. SOHCAHTOA. To help you remember, the sine deals with the opposite and the hypotenuse. The cosine is similar. Cosine adjacent and hypotenuse, and the tangent is the opposite over the adjacent. And that is how we wanted to review and work on memorizing and getting these solidly. This sine, cosines, and tangents are always used in relationship to right triangles, and that is how we like to analyze most things. So have fun. Bye-bye.